This is video number 2 from section 5.3, Basic Log Issues. We just want to continue developing this idea of a logarithm. Just a few things in this video. The first one involves a couple of properties. I imagine that you, if you give these two blanks some thought, that you could fill them out on your own. This first one says, if the little base part and the result part are the same number, then this logarithm will always have the same answer. And hopefully what you realize is that answer will always be a 1. We saw this in the last video with the 77s, right? Because if the base is b and if the answer is b, the only exponent that could possibly work with that would be a 1. And remember, the logarithm is the exponent. In a similar way, this second property says if the result part is a 1, I don't care what the base is, you're always going to get the same answer. And this time that answer would be 0. That is because no matter what the base is, if you want to turn it into a 1, the only exponent that will work to do that is a 0. So just a couple of properties that are probably good to learn and memorize. Let's talk about the calculator. So far we've done everything by hand. Let me see if I can introduce it to you this way. Take a look at this example here, log base 10 of 1,000. This is actually one that we can do by hand. This means 10 to the I don't know equals 1,000. This is my scratch work off to the side, right? Well, let's see, 10 times 10 would be 100, times one more 10 would be 1,000. So I think we've just said that we need 3 tens to make 1,000. That means the answer here would be 3. Log base 10 comes up so often that it is referred to as the common logarithm. And in fact, it's so common that the 10 generally gets dropped. So nobody ever writes this. What gets written instead is simply log of 1,000. If you see a logarithm without a little base, it just means the base is 10. Okay, so log by itself means base 10. The answer to this, as we said, is 3. Well, that's the LOG button that you have on your calculator. It's log base 10. Let's take a look. So on the TIs, the log button is over here on the left. And again, that's log base 10. So we could try that example we just did, log of 1,000. That means what power do you put on top of a 10 in order to get a result of 1,000? And of course, we already learned that the answer is 3. On your handout, the next one written says log 77. The nice thing about having the button on the calculator is, of course, it allows us to work out examples that we cannot work out by hand. Log 77, that means what power would I raise 10 to in order to get 77? Well, I don't think that's a nice answer, even before I hit enter. 10 to the 1 is 10. 10 to the 2 is 100. 77's in between, so I'm thinking, well, it's going to be some kind of strange exponent between 1 and 2. I don't have any way to figure it out by hand. I'll have to just rely on a decimal approximation. So we're saying this exponent, 1.886, etc., is the power that you'd have to put on top of a 10 in order to get 77. You could test that out, right, by typing 10 to the, and then putting that exponent in. Now, I'm going to have to round it off, which means I don't think I'll get exactly 77, but I think I ought to get pretty close. And sure enough, there it is. You can see that's just about 77. So when you're doing tonight's homework, if you've got a log base 10, you can go to the calculator. Otherwise, you should be doing everything by hand. We'll talk later in the chapter about how you can deal with logs of other bases on your calculator. Okay, lastly, in this video, just a couple of restrictions to talk about with regards to logs. Take a look at this example. You'll notice in both of these, there's no little base written, which means, of course, that the base is an understood 10. This is asking me, let's see, if I take a 10, what power would I stick on top of it in order to result in a 0? Well, let's see. It certainly wouldn't be a positive integer. That would make the 10 grow bigger. It wouldn't be a 0 exponent. That turns everything into ones. It wouldn't be a fractional exponent. That roots the 10. It wouldn't be a negative exponent. That flips the 10 upside down. Well, that's all we got. I've just tried every exponent we know about. There is no exponent that will turn a 10 into a 0. This is impossible. This is undefined. You cannot take the log of 0. There is no such exponent. A similar thing happens with the second guy. This would mean 10 to the I don't know equals negative 10. Well, you can play around with exponents all day. We never learned about any kind of exponent that could take a positive number and turn it into a negative number. It's impossible. It just doesn't exist. And so this second guy as well is undefined. You can try these problems as well on your calculator if you like, and you'll see that the same thing happens. What's the moral of the story? Well, what the takeaway from these examples is simply that the result part of the log, meaning this part, the part that's always right there next to the log in the parentheses, this part here can only be positive. If you try to use a 0 or a negative, you get something that's impossible. Here's the way we write that. In the expression log base b of x, the x must be a positive number. Notice we're not saying that the answer to the log has to be positive. I mean, here's one right here, right, where the answer is 0. We had other ones where the answer was a negative in the last video. We're just saying that this portion right here will always be a positive number.